to all. My topic is carbon and its compounds. Carbon is one of the most important non-metallic elements. Anthony Lavoisier named carbon from the Latin word carbo, meaning coal. This is because carbon is the main constituent of coal. Coal is the fossil fuel developed from prolonged decomposition of buried plants and animals. So it is clear that all the life forms contain carbon. Compounds of carbon classification. It is found both in free state as well as combined state in nature. Thus, in the early 19th century, Vesalius classified carbon compounds based on their source as follows. Organic carbon compounds. These are the compounds of carbon obtained from living organisms such as plants and animals. Example, ethanol. Inorganic carbon compounds. These are the compounds containing carbon but obtained from non-living organisms. Example, calcium carbonate, calcium monoxide. Catenation. It is binding of an element to itself or with other elements through covalent bonds to form open chain or closed chain compounds. Carbon is the most common element which undergoes catenation and found long chain compounds. Tetravalency. Another versatile nature of carbon is tetravalency. It has 4 electrons in its outermost orbit. According to Otto rule, carbon requires 4 electrons to attain nearest noble gas electronic configuration. So, carbon has the tendency to share its 4 electrons with other atoms to complete its octet. This is called its tetravalency. Allotropy. It is a property by which an element can exist in more than one form that are physically different and chemically similar. The different forms of that element are called allotropes. Carbon is an inseparable chemical entity associated with living things. Carbon chemistry is also called as living chemistry. Carbon is found both in free state as well as the combined state in nature. Frederick Holler is called father of modern organic chemistry. Semiconductor devices and its properties. Semiconductors are materials which have a conductivity between conductors and non-conductors or insulators. Semiconductors can be compounds such as gallium arsenide or pure elements such as germanium or silicon. Gallium arsenide, germanium, and silicon are some of the most commonly used semiconductors. Holes and electrons in semiconductors. Holes and electrons are the types of charge carriers accountable for the flow of current in semiconductors. Holes are the positively charged electric charge carrier, whereas electrons are negatively charged particles. Both electrons and holes are equal in magnitude but opposite in polarity. Mobility of electrons and holes. In a semiconductor, the mobility of electrons is higher than that of the holes. It is mainly because of their different band structures and scattering mechanism. Electrons travel in the conduction band, whereas holes travel in the valence band. When an electric field is applied, holes cannot move as free as electrons due to their restricted movement. The elevation of electrons from their inner shells to higher cells results in the creation of holes in semiconductors. Since the holes experience stronger atomic force by the nucleus than electrons, holes have lower mobility. Valence band. The energy band involving the energy levels of valence electrons is known as the valence band. It is the highest occupied energy band. When combined with insulators, the band gap in semiconductors is smaller. It allows the electrons in the valence band to jump into the conduction band on receiving any external energy. Conduction band. It is the lowest unoccupied band that includes the energy levels of positive or negative charge carriers. It has conducting electrons resulting in the flow of current. Properties of semiconductors. Property 1. The resistivity of a semiconductor is less than an insulator but higher than a conductor. Property 2. Semiconductors show a negative temperature coefficient of resistance. In simple words, the resistance of the semiconductor decreases as the temperature increases. Property 3. At 0 Kelvin temperature, the semiconductors behave as insulators. As the temperature is increased, it works as a conductor. Property 4. The conductivity of the semiconductor increases when impurities are added. The process of adding impurities to semiconductors is called doping. Semiconductor devices are called such because they are neither prominent conductors nor insulators. These devices maintain a balance between both the properties of conductors and insulators and allow partial passage to the flow of electricity through them. Thank you.